Hello and welcome back to another episode of Effective JaRu, the series where we read effective Java and try to port the items into or to idiomatic Rust. Item 21, use function objects to represent strategies. Alright, so I think the main point here is that, well, some languages have support for function pointers. Delegates, well, delegate is kind of a function object, I think. Lambda expressions, closures, or similar facilities that allow programs to store and transmit the ability to invoke a particular function. Yes, so Java doesn't have that. Java just has objects, but you can have in-place anonymous implementations that you use, actually in-place anonymous types, which is very similar to a cumbersome way to implement a closure because, well, not in this case, but for instance, if you implement something like this, right? This is an anonymous class. This is exactly what a closure can be, and you are actually allowed to catch the environment within the functions that you implement here. Of course, it doesn't care about access, permissions, and so on. It just gives you what you want. It's not Rust, right? But it's that's how that works here. And I think, especially because there is no item 21 here. Is it item 21? Yes. Item 21 here, I will just have an item 21 myself and show how this would work. Closure. So let's have a slice of stuff. Let mut n for numbers be a slice of 1, 2, 3, 4, 9, 0, I don't know. And let's see how this operates for us. And if you want to sort this, we actually have the way to just sort it in place. So this would already or should already be a valid sort call. Let's see how far we get with that. Woohoo! So that already works. But we can also, let's print it maybe. Or let's do some assertions. Let's assert that now that we have sorted this, the 0 is at the front, right? Assert equal, so n0 is 0. So that should be the case. Nice. Thank you very much again. And in the moment we want to sort this by some other strategy or some other criterion. We could, of course, this works because let's look at the declaration or the method signature here. This works because T supports to be ordered, right? So it's not just partial ordering, so it's real ordering. And that's totally awesome. But if you want to have some sort of other ordering, then we would have to jump hoops to make this work. Obviously, that's not required because there's a sort by, which takes a comparative closure, basically a comparative function that is defined like this. F shall be an F in mut that takes two references to our type T and returns an ordering. It doesn't impose any limits on the type T, which is pretty cool. And also I think it's cool that this function will only be there if T supports ordering, right? So we don't impose the requirement on the top level, basically. So it basically is required in order to use a slice. No, we can put anything in a slice, makes sense. And if you support ordering, you get a few other functions possibly. Or if you support clone, you can do this. It's quite amazing the way this works. This allows the interface to basically adapt to what you actually have there. Really nice. So sort by, let's implement sort by and kind of inverse this somehow. I have no clue. So what I want to do afterwards is that this one is the highest value, 9. On the other hand, let's also say that 1, 2, 3, 4, 5, 6, so that 5 is 9 now, right? And now we kind of invert this. So 0 is 9 and 5 is 0. This should now fail because we didn't sort anything yet. Left is 0, right is 9, in lib rs 8. So that is here. So here we want to throw in another sort by. And now the cool thing happens, right? Oh, by the way, the fn mut here, that's important. In the moment you don't want to arbitrarily limit the caller, make it fn mut, because this means you can have a closure that changes its own state, right? And this wouldn't be possible if you would just have an fn here. And it's kind of an inverse hierarchy, so fn mut support fn, but fn doesn't support fn mut, So, and fn once I think supports everything, something like that. I always forget, but at least so far I can recall it that fn mut is really what you want as a default closure to be open to stuff. Yeah, and I think in order to invert this, to invert the behavior, all I would have to do is to exchange. We have, what do we have here? We have references. I think we can just say A and B, and then we can say, well, A comp B, and if we invert this to actually B comp A, we should have an inverted list here. That should be all we need. Comp might be something that comes from a trait that we have to explicitly import, but I'm not sure about it. Yeah, well, that worked. So this is how you implement that, and it's really that simple. And it's awesome, because of type inference, it does all the right things for you here. It's that's in fact a reference, and that as well, but it's basically hidden. It's part of the binding here, even though it's totally in effect. Anyway, so that works. Let's have a look at the book here again and see what you would have to do. And now things start to get crazy. So I think a common pattern is to implement static private types, private classes that implement a certain interface, like I'm not sure if there's an example. Here it is. So that's the comparator interface. That's what you have to implement. It's fortunately generic, so it works for everything. And then you just have to implement it in a private static class. And static classes, they can't have instances. That's what I see from there. So creating them is faster because you don't have to allocate anything on the heap for this. So that's what you want. And then they store this private implementation in a public static final field that contains the comparator. Look, it kind of casts up to the base, to the interface that it implements, right? So the original thing is hidden, the original implementation. But this is the boilerplate you need: private static class string link comp, which implements the comparator string. You have to be explicit about that. There's no type inference. Serializable, I think that's optional, just for example here. Then you have this public and compare, take two strings, and then you do the actual comparison, which is also relatively indirect because you don't call comp on or compare on string, which I think, well, it's a string length comparison. Okay, so in that case is exactly right, even though it's kind of implied that people understand that what it means, that a negative value means this is smaller than the other, and the left is smaller than the other. A positive value means the left is longer than the other, and then if they are the same, then it's 0 that you return. So in Rust, obviously, you return an ordering here, which is more explicit. And you could say, well, it's kind of convenient to do this with the simple subtraction, but on the other hand, this only works in a certain value domain of your values. So basically, if both values are positive, then this works. If one is negative, this doesn't work. And as we cannot enforce positive values in Java because everything is signed, you can actually get into trouble if you misjudge the domains of the values that you compare or that you subtract there. So safety-wise, I prefer Rust. Implementation-wise, oh, look at that. I totally prefer that. On the other hand, if you have something like this prepared, which is not what we show here, then obviously it's less of a problem, because then you can just refer to the string length comparator and you are good. Why does this always pop up? But usually, in Rust, you don't care about instances. You don't have an instance here. It's just a little closure that doesn't even catch the environment, and you throw it in there, and it just works. It's totally awesome. Look, I mean, you can't make it any shorter or more concise. It doesn't work. And it's really lovely. And of course, you can do more complex things as well. You can do pretty much anything you want here and do a lot of stuff. You're totally free here, even though in this case, that was just utter nonsense that I wrote. But yeah, it's quite nice. And, considering Rust is such a low-level language, in fact, these high-level facilities that you have make it so much nicer than many languages in existence. At least it can compare positively with guys like Ruby, for instance, which kind of invented nice closures, right? Quite amazing. So that's just my opinion on this one. Thanks for watching, and have a good day.